Being a farmer, to me, it's providing food for the world, trying to do your part to give everybody a sustainable food source. My name is Brent Hanford, live in Fort Benton, Montana. I grow hard red winter wheat, hard red spring wheat, peas, chickpeas, some lentils, a little barley thrown in now and again. I was born and raised in Fort Benton, where we still live. Grew up on the farm I'm farming today. The pH in our soil has started dropping from neutral pH down to as low as 3.8 in some small spots. Probably saw the first acidic spots in our fields 10 to 12 years ago. At that point, we didn't know what they were. We had them diagnosed as rhizoctonia at one point. A couple years went by, we finally had them re-diagnosed as cereal cyst nematodes. It probably took us 5 to 6 years to really determine that it was acidity when we started seeing these problems show up on the hillsides and the slopes. And then it slowly traveled down into what would be considered some of our best ground in the lowlands.
It could be on the order of, say, $100 per acre of economic loss. My name's Clayton Jones. I'm MSU's Extension Soil Fertility Specialist. And that means that I cover any questions that have to do with nutrients or how to help plants grow. So soil acidity or soil acidification is a problem that we're seeing at increasing rates in Montana. What soil acidity is, it's just like vinegar is acid, battery acid is acid, lemon juice is acid. Our soils are beginning to become acid when historically they have not been acidic at all. So I think the biggest reason to be educated on this problem and to start looking for this problem is the economic consequences are so high. Meaning when you have complete yield loss on some parts of your farm, that can be very catastrophic to your farm profit. What we're seeing on some of the most affected farms is 1,000 to 2,000 acres of, say, a 5,000 or 10,000 acre farm. Those areas that are affected by acid might be producing anywhere from no to maybe half their normal yields.
It's growing on a yearly basis. I mean, you find new spots in different fields. You find bigger spots in the existing fields. As of right now, there's nothing slowing it down. It just keeps growing.
So how do acid soils form? They form by nitrogen fertilizer being applied near the surface or on the surface. That nitrogen fertilizer then getting what's called oxidized over to nitrate. Nitrate is the form of nitrogen that plants like to take up. But in that reaction, the acids also get produced. As those acids dissolve soil, they release aluminum. That aluminum is taken up by crops, and that's what ends up hurting or even killing those crops.
The things we've learned to look for are yellowing and purpling of the leaves. While the plant is usually stunted, it's about a quarter of the height of a healthy plant. It's usually thin. Some of them don't even grow. If you dig up the roots of the plants, you suspect there's a lot of club roots on them. You just don't have a real good root structure to it. And then at that point, I guess you'd start going in with your testers, trying to verify what you saw by the plants.
So how would you confirm that you have soil acidity? You're going to want to soil sample in problem areas and also on the edges of those problem areas where you don't see a problem, so you can compare soil pH between those two. You can either use a field pH probe, or you can ask your crop advisor to send those soils to a laboratory and get a lab pH. What you're going to look for is, do you have pHs below 5? Because if you do, you almost certainly are having growth issues and probably yield issues as well. So if you do find low pH, what should you do? I would recommend a system that I call MAP. That means mitigate or fix the problem, adapt to the problem, or prevent the problem. So by mitigate, I mean applying something that raises the pH, either lime or manure. If you are to use lime, keep in mind that there's everything from free sources in Montana, meaning spent sugar beet lime, up to relatively expensive forms of lime in the form of prilled lime. If you were to lime, keep in mind you're probably going to want to apply somewhere on the order of 2 to 3 tons per acre of lime, and that can be very expensive. The good news is, though, we think you only have to apply those high rates maybe every 15 to 20 years. So on an annual basis, that is not very expensive. You will need to till that lime into the root zone because in Montana we don't get enough rainfall to push that lime down into the soil. We find one-time tillage does not seem to be destructive of soil organic matter and gets that lime down into the root zone where the plants can take advantage of it. You also want to make sure you only apply lime where it's really needed. Because it is expensive, you don't want to be applying lime to your already high pH areas, and that's where grid sampling or aerial imagery can be very advantageous for finding the areas where you need high rates of lime. Some ways to adapt to low pH would be management practices such as applying high rates of phosphorus with the seed, which we have found will tie up the aluminum that's in the soil solution and make it unavailable to plants. Another adaptation strategy would be to select crops that are more tolerant to low pH, such as winter wheat, or select varieties that are more adaptable or more tolerant to low pH, such as a loom spring wheat. If you have high enough pH that you don't have to fix the problem right away or adapt to it right away, meaning pH is above, say, 5.5, you still have time to prevent this problem before it becomes a major problem. So ways to prevent would be using nitrogen more efficiently. So that means soil testing, applying nitrogen when the crop really needs it rather than well before it needs it, using split application, so applying near the time of seeding and then applying a second application only if there's sufficient rain. Other ways to prevent soil acidity are to select crops that require less nitrogen. So those would include the pulse crops such as chickpeas, peas, and lentil. Also the perennial crops such as sainfoin, alfalfa, or grass. Also barley uses substantially less nitrogen than the hard red wheats. Other ways to use nitrogen more efficiently would be to only apply nitrogen where it's needed or apply it where it's needed the most, so a variable rate application rather than uniform application across the field.
If you think you have it and it's just getting started on your farm, then I would definitely try to get ahead of it, because it's a lot easier to get ahead of it than it is to play catch up, and a lot less expensive.